I can't believe you said that. She did that perfect. I don't know if you play this one. This
That's my
color?
move for today.
It gold is not. I have red skin.
What are you doing?
I'm not doing anything. I'm waiting for the bell.
No, you were doing something.
Can I go?
You were. You gave me a weird look.
Can I go to bed?
Yeah, I was gonna tune this in and then
Thank you. I thought you were talking about doing this.
I had the big
I
walked in and the door was open.
You got plenty.
There, the door and it's full of books.
No.
Yeah, yeah, I brought that book
Only
back.
how is it getting
Why?
I'm going to.
What time are you leaving?
Moving up on the
Look at this.
I saw.
You okay?
It's not coffee.
Really?
Tyler.
Oh my god, it was so Oh my god. I would never, literally never have anyone like that. That would.
My dad could go.
Oh, yeah.
It's not even on the well.
Jet's not here today.
It is on the field.
Probably like 8 pumps per
They didn't mark him yet. Naomi and Elise.
You stay. What numbers do we get on Monday?
52, and then we started the bookwork on your own paper, 53.
You got me one.
All right, to start off today, I need y'all to get number 53, the book assignment, out of your binder. See where you left off last time. Okay, so last time we spent roughly about half the class talking about the notes from section 5.3, looked at some example equations to solve, talked about what the directions could ask you and how your answers could look different, and then roughly 30-40 minutes for the book assignment. So you should have realistically only gotten a couple of those finished, but I did ask you to try to do 2 or 3 more outside of class, even though you didn't have to have the whole thing finished. So that way you had to think about it again, and potentially maybe found a few questions to start off class that you know that you need help with. So remember, we do have a 50-point major assignment, a 50-point quiz over section 5.3. That will not be next class. That'll be the class after that. So that'll actually be Wednesday of next week. This is a B week, not an A week. But today what we need to do is finish up and get the rest of your book assignment questions asked and answered, and try to get some or most of the worksheet that you picked up on your way in, 54. That is a good example of what you should expect the quiz to look like. So that will be, you should really try to treat that as a practice quiz. So you may not have any questions right now, but if you took my advice and tried to do 2 or 3 more questions for homework, you may have found a question or 2. So if anybody has those ready to go, I would be happy to start off class with those. No point in waiting if you know you need to ask. So anything from the book assignment that I can help you get started on? Sure, 23. As always, some of you might not be quite to question 23 yet, and that's fine. You did not have to have this finished coming into today, but as you know, I'm not going to go over 23 multiple times. So if you haven't made it to 23, you can either choose to follow along with us, or you'll need to watch this part of the class recording later to make sure that you get that. Okay, now I may not say this for every question that you guys asked today, but I think one of the best things that you can do for yourself is everywhere there's a trig function, try putting an x instead. So instead of a tangent x, just think of it as an x, because however you would solve this is exactly how you should solve this. The only thing that should be different about this is unit circle at the end, and then writing our answer one way or another depending on the directions. So when I look at this, I know that you would be tempted to divide both sides by x, but hopefully I emphasized that enough in the notes not to do that. So I would want to subtract it over, which is the same as subtracting over a tangent. The next thing I would want to do here is pull out an x. Anytime there's a GCF, that's probably a smart move. So just like these both had an x and I could factor it out, these both have a tangent x. and I can factor it out. And then to finish this, I would set this equal to 0 and solve, set this equal to 0 and solve, and get my solutions that way. So same over here. Set tangent x equal to 0. That one's already solved. Set 3 tangent squared x minus 1 equal to 0 and solve. For this one, you're going to have to add the 1, divide the 3, take the square root of both sides, which the most common mistake there is going to be forget plus or minus. So I'm going to highlight that as it comes up. And before I start to recognize this on the unit circle, we have to remember how to take the square root of a fraction. And we probably will need to rationalize it before it looks familiar. So our solution should come from when tangent is 0, and also where tangent is plus or minus square root of 3 over 3. Okay, are you okay up to this point? Okay, so now, because again, most of this is pretty much the same as what you would do over here, but what's going to be unique at the end of each of these questions is you're going to have to know the unit circle well enough to be able to label where tangent is 0. So since tangent is sine over cosine, tangent's going to be 0 when sine is 0. So that would be these two places. But also where it is positive or negative, square root of 3 over 3. And you can save a lot of time if you memorize those 3 tangent values so that you don't have to search for them. But that could be pi over 6, everything coterminal, 5 pi over 6, and everything coterminal, and 7 pi over 6, and everything coterminal to that, and 11 pi over 6. So, as we talked about in the notes, that is perfectly fine. That is technically correct. The back of the book is going to look wildly different though, so let me address why they did that differently. So these two that I have in gray, these two are both equidistant. You could add pi to get from this one to this one, and add pi to get from this one to this one. So we can actually combine both of these statements, and instead of adding 2 pi in, we could start at the first one and just add 1 pi in. So this is the same as both of those. Also, I could knock out the pi over 6 and 7 pi over 6 answers because they're equidistant. Add pi to get to this one, add pi to get back to where I started. So you could just do pi over 6 plus 1 pi n. So that in purple represents both of those. And probably the last answer that they put in the back of the book would be 7 pi over 6 plus 1 pi n. This is, oh, that's not correct. This would need to be 5 pi over 6 plus pi n. That represents both of those. So I don't have any preference, but you need to be able to check your answers and make sure that they're okay. Okay, anything about the second half of the question, unit circle parts, or why my answers look like this instead of why they have the plus 2 pi n, plus pi n, any of that stuff? Okay, somebody else have another one ready? Sure. 26? 27, okay. So secant squared of what angle minus secant squared of the same angle equals 2. So at the start of the last question, I said I wouldn't do this on every single one, but again, if you're struggling getting started on some of these, just rewrite it. Everywhere there's a secant x, replace it with an x, and however you think you should start this is probably how you should start this. This is a quadratic, so let's put everything on one side set equal to 0. This is like a quadratic, So put everything on one side set equal to 0. This looks like it wants to be factored. And however that factors, this should factor the same way. X minus 2, secant x minus 2. X plus 1, secant x plus 1. Should factor in the same process, the same thought process. Okay, unlike algebra, where I could just set this equal to 0 and solve, and this equal to 0 and solve and be done. Over here, I need to set this equal to 0 and solve, and this equal to 0 and solve. And now I'm about ready for the unit circle. Now, of course, I don't know these values because when I memorize the unit circle, I don't memorize secant values, but you can take the reciprocal of both sides. Reciprocal of -1 is still -1. Then you need to think about where these three things happen. Cosine is -1 one time. Cosine is positive 1/2 in 2 places. So, because the directions say solve, you could either say pi over 3 plus 2 pi n, pi plus 2 pi n, and 5 pi over 3 plus 2 pi n. Or you could actually get away with doing all of these in one statement, because to go from 1 pi over 3 to pi, we're adding 2 pi over 3. And then if you add 2 pi over 3 again, you get here. If you add 2 pi over 3 again, you start getting coterminal angles. So you could just list the first one, pi over 3, and say just go 2 pi thirds. Integer multiples of 2 pi thirds. This one statement is equivalent to all 3 of those. This one repeats 3 times as often as those do. Okay, did you see what you needed out of that? Oh, okay. Was anybody else going to ask about 27, have something else while it's still on the board? Okay, somebody else have any others ready? Sure. 37? Okay, 37 is a little trickier because we have 2 different trig functions. We've got a cosecant and a cotangent. So that's almost like 2 different variables. It's kind of like an x plus y equals 1. But since these are related in some way, we can actually work with them a little bit. So there's no basic arithmetic or basic algebra to be undone. No undoing, add, subtract, multiply, or divide, nothing like that. Really, there's not much you can do to start this one, but you could say, well, I know this is the same as 1 over sine, and I know this is the same as cosine over sine, and I don't know if it's a good idea or not, but these already have a common denominator, so it's not a big deal to add those fractions together. I'm going to put a big star right here because this is going to be important later. But I can multiply both sides by sine, so I don't have fractions. And now this looks like one in our notes. This is the one I suggested. Try not to do this with algebra. In theory, you can square both sides and get the answer right, but it's going to be a pretty long question, and you may be creating more extraneous solutions. Instead, just think of guess and check process, because there are only 4 places on the unit circle where sine and cosine are 1 apart. So I'm going to add 1 to cosine, which would be the x value, and see if it equals the sine, the y value. If it does, then that's the spot that could be a solution. If it doesn't, then it's not a solution. So at 0, if I add 1 to cosine, I get 2. That does not equal sine, which is 0. So that's not an answer. At pi over 2, if I add 1 to cosine, I get 1. That's equal to sine, because it's 1. So pi over 2. Add 1 to cosine equals sine. Looks like pi is okay as well. And then down here, adding 1 to cosine makes it 1. That does not equal sine, which is -1, so that's not correct either. So I'm just adding 1 to each of those cosine values to see if they equal sine. I'm just doing guess and check. Now, the reason why I said this question is kind of tricky, and even if you are not to question 37 right now, you need to make sure that you pick this up. You should, especially on a quiz or a test, want to check your answers. You shouldn't just say, I know how to do this, I usually get these right, let me circle them and move on. You should want to plug them in and make sure that they work, because it'll help you catch that you make some silly mistakes. That's why the assignment started with questions 5 and 9 where you only checked. But also, back to this star, some algebra steps create extraneous solutions. When I multiplied both sides by sine, this and this are equivalent, but this looks like it's always okay, and really sine can never be 0. We can't divide by 0. So not only should you want to plug these in to check, sometimes it's necessary depending on the algebra steps that you do. So if I plugged in pi over 2 into here, or this, the same things, 1 over the sine of pi over 2 is like 1 over 0. And you can't divide by 0. So it doesn't matter that it makes it look like it solved the last step. It solves the last step, but the step before that, that's not a possibility. This is what we call extraneous. You should not leave it as a final answer. My work's right, my arithmetic's right, my thought process is right, but because of this step, I made up a fake answer that doesn't really solve the original question. If I check pi, I could plug pi into this and I would get, oh, I'm sorry, I lied. I knew the outcome, so I was cheating a little bit. When I plug in pi over 2, I get 1 over 1 and 0 over 1. 1 plus 0 equals 1. This guy is fine. Plugging in pi gives me 1 over 0 and -1 over 0. But I can't divide by 0. This was the extraneous one. Extraneous means that you didn't do anything wrong, it just doesn't solve the original problem. Things like squaring both sides of an equation often creates extraneous answers. Multiplying both sides by a variable like I did right here, I made it go from where I could see that sine could never be 0 to this where I can't tell that it matters if sine is 0. So that's why that's occurring. So I know that you don't need to do this in your book assignment because you have other ways to check your answers, but you need to know plugging them in to check your answers is a good idea just to catch arithmetic mistakes, but it's also important to not give any extraneous solutions. Okay, was that enough for 37? Okay. Was anybody else going to ask about 37 need something specific? Okay, anybody who has not asked a question yet, have one ready to go? Yes. 29? Sure. So sine of what minus 2 is the same thing as cosine of what minus 2. So what do you think we should do first? How can I get rid of this? Okay, so add 2. And if I add 2 to the other side, that goes away as well. So that's nice. Makes the question a little more simple. Now, you can do this algebraically. You can square both sides and go through that process. It's going to be a longer question if you go that route. This is another one where I would say that this makes sense to not do algebra and just go straight to the unit circle and think about where sine and cosine are the same. Every point that you memorize on the unit circle, there's only 2 times that sine and cosine are exactly the same. At pi over 4 Sine and cosine are equal. And at 5 pi over 4, sine and cosine are equal. So, since there's only 2 places where that's true, I don't need algebra to try to simplify the problem for me. I can just think of what they are. So, pi over 4 and 5 pi over 4. And because the directions have changed, once you get to question 29, it would be incorrect to do the plus 2 pi n on each of those. You should not be putting the plus 2 pi n based on those directions. Okay. Is that okay? Is that enough? Yes, sir.
49.
Question 49. Also, before I forget here, I don't know when, but there is a fire drill today. This year they only give us a time window, so it's supposed to be somewhere between 12 and 4, but it's never going to be during lunch, I don't think. So there's a good chance that we'll have a fire drill during this class period. So just a heads up. It may scream at us at some point, but I don't know exactly when. Okay, you said 49?
Yeah.
Okay. So this one is one that you don't need to worry about for the quiz, because this specifically says you need to use a calculator. So we can't solve this by hand. By hand, we could subtract the 2 and divide the 5. You should know that there's answers to this because sine exists everywhere from -1 to 1, and -2/5 is between that. But that's not an angle that we memorize. We memorize like 3 angles per quadrant, but there's like 90 angles per quadrant if you're thinking in degrees. We only memorize a couple places, but this one still exists. So, what they're wanting us to do is to solve this with the calculator and round to 3 decimal places. So, if you go to your calculator, I would graph one side of my equation, sine, with the other side of the equation, -2/5. And these are going to be equal when these two intersect. Now the directions say 0 to 2 pi, which is why my calculator is in radian mode. 0 to 2 pi is implying radians. And I only care about 0 to 2 pi, so I would change the window settings. Only go as far left as 0, go as far right as 2 pi. Then when you graph, again, the blue represents sine, the red represents -2/5. So where these are in the same place at the same time are the 2 solutions. Now you can hit trace and you can get it kind of close, but kind of close is not really good enough. And I know some of you like to use the table. The table is also not good enough. Usually the table has you jumping by integers, and the answer is probably going to be a decimal because it's saying round to 3 decimal places. So again, you don't have to worry about this for your quiz, but I can promise you in calculus, well, on the calculus AP exam, half the points come from calculator stuff and half come from non-calculator stuff. They expect you to be able to do things like this. So I try to sprinkle it in throughout the calculus year, but we also have to learn calculus. We don't get to just stop for a day and talk about using your calculator. So I would find this spot within 3 decimal places by doing second trace and picking intersect. I'm guessing last year you probably used a 0. Did y'all have teachers that did this last year? Second trace and picked 0 for x-intercepts? Okay. I'm doing intercept just because that's how the way I graphed it. So you have to enter to identify your first curve, enter to identify your second curve, hit enter to skip guess. Then your calculator will do the work and it will bounce this point back and forth until they're at the same place at the same time. So they both have a value of -2/5 at 3.553. And over here, so you would need your cursor to be a little bit closer to it so your calculator knows which one you're asking for. So get a little bit closer. Second trace, calculate intersect. Second trace, calculate intersect. Okay, it's going to ask for first curve, so hit enter. Second curve, hit enter. Enter to skip guess, and then it will find the intersection that's closest to where I had the cursor. So they also are both equal to -2/5 when x is about 5.872. 5.872. So they exist, they're just not things that you would ever think of without a calculator. So you can get those from a graph. Again, not really important for this class and this section, but for those of you going on the calculus, the better you are with the calculator, the smoother some things like that will go for you. They expect you to do those things. Okay. Was there any follow-up questions to 49? Okay. Then let me give you just 10 minutes. I'd like to set like a 15-minute timer, but again, I have no idea if the fire alarm's going to be today, this period or not. So I want to try to squeeze in as many opportunities for checking in and helping you out. So 10 minutes from now, I will bug you for another round of questions. Okay, just about 2 more minutes, and then I will try to get some more questions out of you. Okay, let's see if I can help out a little bit more here. So, anything else you guys have tried in those 10 minutes? Well, said 31? Okay. Oh, 31 is an excellent question to ask. I did bring this up in the notes, but I know not many of the book questions ask this. So, looking at 31, I can instantly see that this is going to be a certain type of question because I've got some sine stuff and I've got some cosine stuff. So that's essentially like two different variables. And we can't solve an equation that has two different variables. So, the trick is, for this type of question, is at some point you have to give up on all your conventional stuff. Remember the first Pythagorean identity and realize that you could say sine squared is the same thing as 1 minus cosine squared. So over here, instead of saying sine squared, we can put 1 minus cosine squared. I know that's an improvement because now I only have cosines in my equation and not cosines and sines. So that's how I know that that was a smart move. And it should be more similar to the other stuff now. So we could distribute this 2. We could take away 2 from both sides. those 2's just cancel and go to 0. This is like a quadratic, so we probably should move everything over one way or the other, set equal to 0. And I don't know, both of these have a cosine, so factoring out a GCF of cosine is probably a good idea. So it looks like my answer should come from when cosine's 0 and when cosine's negative 1/2. Cosine is 0 in a couple places, negative 1/2 in a couple places. I have to check the directions before I write my answers out, but this one I should not be putting the plus 2 pi in because it doesn't say solve. It says give solutions between 0 and 2 pi. So I would say pi over 2, 2 pi over 3, 4 pi over 3, and 3 pi over 2. I would say all of those should solve that. Now, this is a good question anyway, but especially that first step. I'm not in charge of putting together this year's quiz, but I can tell you in the last few years we've had at least one question like that on the quiz where you have to know to make that change. Otherwise, you're not going to be able to move forward. And I'd like to check this one. Yeah. Just to be sure, because I went through it pretty quick. But yeah, that's what the back of the book has. Okay, anything else about 31 before I take something else? Okay, anybody else have another one ready? Yeah.
45.
45. Okay, and I think this is the only one I don't have a recording of on the class website, so I will try to, well, that and 43, but I have 43, I just need to put it on there. So let me go ahead and record this one. Okay, so to start off 45, there's a couple basic steps that we could do. We could undo this subtraction with adding, and we could undo the times with dividing. But what is unique about these questions in 39 through 46 is that this is not just an x. It's a 2x or a 3x or a 1/2 x. It's considered a multi-angle equation. So when we saw this in the notes, my suggestion was to pretend like it is just an x for a second, work it normally. Once again, it's a benefit if you memorize your tangent values because you're going to save a lot of time. Otherwise, you're going to have to do some investigation there to figure out the two places where tangent is square root of 3 over 3. This question says solve, so I'm tempted to say x is pi over 6 plus everything coterminal and 7 pi over 6 plus everything coterminal. But the one catch was we never really solved for x, we just solved for 1/2 x. So again, I pretended like it was an x to help me move forward, but it was really a 1/2 x, or x over 2, same thing. So what I really want to do to this equation is multiply this by 2 to get it to be x equals, but to multiply this by 2, everything has to be multiplied by 2. And then multiply everything by 2 on this one too. Now I really know what x equals. And since the directions just said solve, your answer should be in that format. You don't need to do anything else. So it adds this one extra step. You needed to multiply everything by 2 to go from 1/2 x equals to x equals. Okay. Anything about that one y'all want clarification on? Okay. And then I'll get that posted to the website. Actually, give me just 2 seconds and I will try to get 43 posted. And that gives you a minute to make sure you don't have something else ready to go.
So that was 45.
Okay, one more try before I reset our timer. Anything else y'all have ready to ask? Okay, then let's aim for another 10 minutes. But again, I don't know when this fire alarm's going off, so if we get interrupted, then I'll just add however much time was left when we get back. Also, I don't know if I mentioned this on Monday. I think I mentioned that it was supposed to happen. But for any classes that you're trying to exempt the final from, that form is only opened from this Monday to next Monday. I think next Monday. So if I was you, I would turn it in and submit it as soon as possible. It may just be till Friday or something. I could be wrong. But that's one of the requirements, is that you submit it by the deadline. So
Where do you find that form?
if you check your school email, it should be in the student announcements. You must have missed it today when you checked. I wish I didn't have to check my email every day.
2 to both sides to start off. And both those minus 2 go away, makes it easier. And then you're left with sine and you get the cosine. And then you can go around and get a circle, and there's only 2 times for sine and cosine are exactly the same. Okay, so what it does look like you were checking like quadrantal angles, and sine and cosine aren't going to be equal at those. So they're going to be equal when they're the same thing. So that would be right here, like they're both. That, 5 or 4 in these two, and down here, they're both this. So the only 2 times sine and cosine are the same. So 5 or 4 and 5 are the same. The quadrantal angles make sense to test if it's like sine plus 1 equals cosine. Like if you know the values are supposed to be 1 apart, if these are the only 4 times that they're 1 apart. But on that equation, if you add 2 to both sides, you wouldn't know when they're equal. So. And you do not have to have this practice quiz completely finished before next class. But by the end of next class, you need to have it finished and your questions answered. So the more of the practice quiz you can do, the better shape and the easier next Monday will be. Again, we don't have class on Friday because it's a B week. Next week will be an A week.
Do you put plus or minus whenever it's the square root? Like whenever a square root pops up, and I just leave it plus or minus? No. But if you put the square root of something, that one that goes to the we're just zero means. Well, once you have it, still have the solution. That sounds right. So it seems like check it. Did you not plan it at all? She split it. I think she was 11:27. So what'd you do? At least it's not much. But I don't even use
What is that going That's all. That's horrible.
Oh, but she's important, right?
Well, that takes a lot of work to show. One that'd be a bit like a little dog.
Yeah, this is the worst. And then right here, it's just sad.
But you can take them out, just in really deep. Hey, they had car wash. Oh my god. Like, there's
You can't believe it.
so this the little space.
Yeah, Arkansas is winning tonight.
What, that's the
What? It's an I didn't know that was a good site. It's there's one on crossover and there's one on. Does it have I went on.
Have you seen the one here?
And I found theirs. And
real
I
bad.
just put it like a little stuff.
Do you have a picture of Ted Mullins there? Where does Tyler live? Oh my god. Who did that?
I think just go to New York.
Who did that?
So it's not Saturday here. But we're not going. So do all four. I think that's a good idea.
Wait, where are you, boss?
Okay, I want to try to squeeze in a couple more questions. Again, I have no idea when this fire drill is, but my guess would be probably the last 10 or 5, 10, 15 minutes of class. So just based on what they've done in the past. So, has somebody found anything else from the book work that I can help with? Yeah.
Can you look for 39?
Sure. 39. Looks like that. So we could start off by adding the 1 over and dividing the 2 over. Okay, I assume you're okay to that point. This is a multi-angle one, so I'm going to highlight it so I don't forget about this. But I will temporarily pretend like it's just an X and work it from there. And if it was an X, my answers would be pi over 3 and everything coterminal to that, and 5 pi over 3 and everything coterminal to that. The only thing you need to do in addition is to remember that you didn't solve for X, you solved for 2X. So we still need to do one more step on each of these. Divide this by 2, divide this by 2, and divide this by 2. You're going to divide one thing by 2, they all get divided by 2. Same thing with this. Go from 2x equals to 1x equals by dividing everything by 2. That's what we were aiming for. Okay, is that enough? Okay, others?
Can you like review one more time like how to condense it, like instead of writing all 4 answers, rather just like.
Okay, well, like if it was in the middle of each quadrant, you could just say, here's where the first one is, and instead of saying go all the way around plus 2 pi n, how much would you have to go from pi over 4 to 3 pi over 4?
Or
Half a pi. And how much would you have to add to get from here to here? And half a pi and half a pi. Since these are all equally spaced out, you could just add multiples of pi over 2. So this would be the one statement that you could do for those 4 points.
So if they're not like evenly spaced, you can.
That's correct. Now, if it's something like this, where 2 of them are evenly spaced and 1 of them is not, you could condense it into 2 statements, because you could do one statement for these 2 and then one statement for those. You see how my red dots are equally spaced?
You'd say like pi over 2 plus pi. Even.
Correct. That would get both of those. And then this one's not evenly spaced with anything, so he would need his own statement. You couldn't condense that one.
Can you do 35?
I can. Or I can try.
I tried to figure out what to do by looking at the packet, but I couldn't figure out like the next step.
Okay, so these 2 are basically like different variables, so that's a problem. I can't rewrite either one of those with any basic algebra, but you could maybe make this one look different with a different trig identity. You could maybe do that.
About it, so it sounds like
Okay, well that's what I would do. And then to make this not have any fractions, I really would like to multiply this by sign so that those cancel. But then you have to multiply everything by sign. Now, unfortunately, I need to put a star here because I may have just created some extraneous solutions. Any value that makes sign 0 cannot be a solution to this because it would be undefined. So I'll have to double check my answers when I'm done. But then you could divide both sides by 2. You could square root both sides, which would be plus or minus. But plus or minus 0 is just 0. 0 doesn't care if he's positive or negative. Sign is 0 in 2 places, at 0 and pi. So those would be my 2 solutions, unless one of those is extraneous. Again, right here, multiplying everything by sign I may have created an extraneous solution. So I need to consider plugging in 0 into the original problem. 2 times the sine of 0 plus the cosecant of 0, which would be 1 over the sine of 0. That doesn't make sense. You can't divide by 0. So 0 is considered to be extraneous. Then try to plug in pi. 2 times the sine of pi. And the cosecant of pi would again be 1 over 0, which is also undefined, so maybe that one's extraneous too. Maybe there's no solutions. Did you check the answers yet? I'm thinking no solutions, but yeah, no solutions. The 2 solutions that my algebra came up with, both of those were extraneous. Neither one of them worked because those values were undefined. And again, when I go from here to here, the reason why I'm getting some answers that don't really work is because right here it doesn't seem like there's anything wrong with 0 or pi. The previous step, you can see why you can't plug in 0 or pi, because it would make this denominator be 0 and you can't divide by 0. That's why it's a good idea to check your answers, but sometimes it's absolutely essential. Nothing worked. No value of that will ever be true. Just for some kind of bigger picture knowledge here, this would not apply to us in our class because we would do no calculator. But if, like on the ACT or something, or I don't know if you guys are aware, but do you guys know what the GRE is? You ever heard of the GRE? The GRE is like the ACT test when you're in college if you want to go to grad school. So you could do this like the last question, and you could try to graph it and see. This would be negative. You could graph one side of the equation in blue, one side of the equation in red, and the fact that they never intersect means that there's no solutions. At least no solutions between 0 and 2 pi. So just a different way to visualize that. Okay, so assuming that the fire drill does not happen this period, which I think it will, we got about 20 minutes. So go ahead and keep on going. And I'll stop bugging you for questions, but if you guys have something, please bring it up here or call me over, one or the other, so I can help.